Hello, favorite students. Welcome to part 2 of angles. If you are here, I am hoping that you already checked out part 1. I say that because some of the questions that we're going to go over today are actually going to test you on some of the combinations of facts that we went over in part 1. So if you haven't already done so, check out that video and then come right back here to check out the rest. There are 180 degrees on one side of a line. There are also the sum of the angles in a triangle are 180 degrees. And you've got the sum of the angles in a polygon are simply the number of sides minus 2 times 180. So, what is there left to cover? Well, today, my friends, we're going to be entering a parallel universe. Okay, so let's delve a little deeper into this parallel universe. What we have here are two parallel lines, L and M, and then a line that is going through both of those parallel lines. What we're going to identify is the Z. So first thing that I see is kind of a backward Z. And the interior angles of the Z, I'm just going to label them A and B, are going to be equal. So A, B, alternate interior. You also have a funky looking Z here. If you were to do it sort of like this, and this angle, say C, and this angle D, are also equal, so C and D. Aside from that, you've got a couple of other pairs of angles. Alternate exterior angles are exactly what they sound like. They're on alternate sides of the line, but on the exterior. So this right here, we'll say E and F are also equal. And then lastly, we have corresponding angles. So these are angles that are in the same position as another angle. So for this, it would be, let's just call this G, and then that would be corresponding with C. There's a couple other corresponding angles here. We won't go over them, but you get the sense. Finally, let's cover vertical angles. Vertical angles are not just unique to parallel lines, but they are in fact unique to intersecting lines, sets of intersecting lines. So in this scenario, we have a couple pairs of vertical angles. One of which is, let's go with a different color here. Okay, G and D, because they are right across from each other. We also have C, and we'll label this one H, which are also vertical angles and also equal to G and D. The other set here, finally, is F, A, and then B and E. Those are all vertical angles and corresponding angles. All right, folks, that's it. Let's check out a practice problem. All right, so here's our first question for today. In parallelogram ABCD below, line segment AC is a diagonal. All right, we can see that in the figure pretty clearly here. The measure of angle ADC is 38, labeled for us kindly, and the measure of angle BAC is 61, also labeled for us kindly. What is the measure of angle CAB? So let's really break this one down. What I'm going to suggest is that anytime you get a parallel line angles question, go ahead and just extend the lines here so that you can better see the Z. Keep in mind that we not only have this diagonal to highlight and extend, but we also have the two sets of parallel lines on either side of the parallelogram. All right, so if we take a look here, one way to think about this is that 38 degrees right here corresponds to this angle right here. And then you could easily apply the rule that there are 180 degrees in a line. So we would simply do 180 minus 38 minus 61, and we would get 81 degrees as our unknown. Choice D. It does help to know that alternate interior angles of parallelograms are also equal. So in essence, this angle right here is alternate interior with this angle right here. And by the same token, the 38 degrees that you see right here is also going to be the degree measure right here. So you could also approach it by saying, well, there are 180 degrees in a triangle, what we covered before. So you would do the same steps, 180 minus 61 minus 38, and you would get 81 degrees again for your unknown angle, which is, again, alternate interior. All right, next question here. This is going to deal with both facts, both the parallel lines looking for the z and the vertical angles. So in the figure above, below, let's try that. Point B is on a line segment AC. You can see that, thank you very much. And point E is on line segment AD. Yes, indeed, we can see that. What is the measure of angle GAF? So, let's start off by figuring out what we know. So for instance, the 65 degrees that you see in the corner here is going to create a vertical angle with this right here. It's also going to be alternate interior with this angle right here. Find your Z, bang, there you go. And then that angle right there is also going to be vertical with this angle right here. We are very close to getting our answer here. Next step is to keep in mind that we have 180 degrees in a triangle. This is the triangle that we're interested in right here. So we've got 90 degrees plus 65 is equal to 155. And now we're going to subtract 180 degrees, 155 degrees, and we're going to get 25 degrees right here. And then again, we've got vertical angles, so GAF is in fact 25. Easy as pie. All you got to do is find your Z and find your vertical angles. Congratulations, students who have made it back from the parallel universe all in one piece. So next time on angles, we're going to be covering something a little bit different than parallel lines. So when you have a chance, check out part 3, the final episode of Angles. Signing off, this is Gina Moustakis of The Learning Edge, and I'll see you next time.